Another day, another book review. Today we're going to cover this book here, Principles of Computer Hardware. Now this is the 4th edition, which came out in 2006. So it is an older book, but it's still an excellent book if you want to get into the basics of digital design and computer architecture. There's also a lot in here on assembly language programming. So let's crack on and let's review Principles of Computer Hardware. So let's have a look at Principles of Computer Hardware. Now, as I said, I have had this for over a year. Now, the first chapter here, in fact, I'll go through the contents again so that you can have an indication of what's in it. Now, the writing's a bit smaller in this, but I think you should be able to make it out. So we've got our Introduction to Computer Hardware, Gates, Circuits and Combinational Logic, and then it goes on to Sequential Logic, and then it covers Computer Arithmetic, Instruction Set Architecture, Assembly Language, Structure of the CPU, Accelerating Performance, Processor Architectures, Buses, Input and Output Mechanisms, Computer Peripherals, Computer Memory, Operating System, Computer Communications. Now, as I said, this is an older book, so there's a lot of it stuff that's maybe out of date. So for example, maybe the introductory chapter here. So the chapters that I was really interested in, I found really useful, were chapter 2 on Gates, Circuits and Combinational Logic, Sequential Logic, Computer Arithmetic, Instruction Set Architecture, Assembly Language, Structure of the CPU. Now, some of the accelerating performance was interesting, especially the bits on pipelining architectures and a bit on the RISC revolution. And also there's a part up here in the processor architectures when it looks at particular architectures. For example, here it picks out the ARM RISC architecture. But the later stuff here on buses, a little bit in the buses and the input-output mechanisms was interesting as well. Computer peripherals was a bit out of date. And also the computer memory. I never really covered much on the computer memory. There is a little bit on the operating system, which was quite interesting. And I never bothered covering computer communications. So there is quite a bit in it. Now, the idea is that you could take this book and from knowing absolutely nothing, you could be able to work your way up to being proficient in being able to possibly design a nice little CPU and an assembler of your own with your own instruction set. Now, the first chapter, as I said, it's about computer hardware, so it goes through some basics. Again, some of it is a bit out of date, but it's still worth a nice easy introduction and a nice read, you know, and it's got bits about some history of the computing. So it's well worth a read just to get started on in the book. But you can always, if you want, and you know a little bit about computers, you can also obviously skip the first chapter if you want to. So we really start here at Gates, Circuits and Combinational Logic. So it gets through a kind of typical university or college course on fundamentals of the simple gates, the AND, OR, the NOR, the NOT, exclusive OR, and so on and so forth. So it works its way through the sort of typical structures that you would see, and the truth tables and how we generate the truth tables. Now, an interesting thing here is that it did use a simulator which is called Digital Works. You can see it's 1995. So I haven't gone online to check and see whether this is still available. It may well be, but you don't need to use this. You can use other freeware software for digital design. Now, for example, the one I use is Logisim. So you could take these circuits and very, very quickly build them up in Logisim. So it's a nice book if you want to teach yourself the basics, and it's hands-on as well, because you can download the software tool and you can actually build the circuits and you can see them working. And I would suggest that you do that, because that's how you like an excellent way of learning this material. So it goes through bits on clock, multiplexers, and there's a lot of stuff in it as the theory stuff as well. So you get introduction to Boolean algebra, and you would have to go through this at least once to get some knowledge in your head about in effect the mathematics of your digital logic. And you've got the NAND and the NOR implementations here as well, and the kernel maps. Okay, so I'll quickly flick through this, because you've got an indication of the types of circuits that we can build. So it's all a combinational logic circuits, and there's quite a bit on the kernel maps in this book as well, which is excellent. And it goes through individual blocks. So for example, the multiplexer, the demultiplexer, and there's a tri-state buffers here as well, and the buses, how a bus would work, and so on and so forth. And again, you can build all these up yourself. And there's a bit on programmable logic families, okay, which gives you a nice introduction about programmable logic arrays. But it's kind of basic stuff, but it's just what you need to get started. And there are plenty of questions at the end as well, if you're interested. Now, again, goes on to the next topic, which is a sequential logic. So it's all of our flip-flops. So we get our RS flip-flops, and how to analyse the flip-flops in the detail that you want, and the D-type flip-flop, and there's nice little circuits as well for counter circuits and stuff that you can build up yourself, and practical sequential logic elements. It shows some practical elements here, so you can see them actually in the actual IC chip realisation. And there's a clock flip-flops. So it goes through in really good detail. So the master-slave here, RS flip-flop, and I imagine that it will go through the JK there, it's the master-slave JK flip-flop as well. A nice little summary at the end of each of the section as well, and also counters, and lots of stuff on counters, and the asynchronous as well as the synchronous counters. And again, you can build these up, and you'll be able to get the out the timing diagrams and stuff for it. So it's a nice subject actually for self-learning. It's not as if it's really difficult to comprehend. There's just a lot of it, and it just needs a little bit of practice to build up some nice circuits. And it's fun as well. It is just a fun topic. Okay, so that's that second chapter there. So that's a kind of typical route that you would take if you were learning at a college or a university. Now there's another chapter here on computer arithmetic. So again, bytes, bits, words, and the characters, the number bases, and conversions, binary coded decimal, and a bit of error detection. This stuff might be a little bit out of date. Parity encoders, different codings, data compression. So I've never really covered this stuff in the book. It wasn't really what I was interested in, but there is some detail there. So binary arithmetic, and building up a half adder and full adder. So how to do addition, subtraction, multiplication, and division really within a Boolean system, like a computer. So we've got 1's complement, 2's complement, and we've also, interestingly, there is a section on floating point numbers, which sometimes tends to be missed out. So there's good bits here, normalization of floating point numbers. So it gives you a good indication. Floating point arithmetic, and also sections on multiplication, division, and so on and so forth. So just the basics of computer arithmetic and how we add, subtract, multiply and divide within a computer. Okay, so that's that section there. It was quite good, but it really starts for me, the book here at chapter 5. So this was the stuff that interested me in particular, and the reason why I actually got the book were these chapters, the next 3 or 4 chapters. So there's the instruction set architecture, and the nice thing about it is that it's very wordy. You know, and there's lots of diagrams, lots of words, lots of explanations, and this type of thing I find is excellent, you know, where you come down at the bottom level, digital logic, the microprogram, machine level, assembly language, operating system, high level, and then an application. And it gives you a good indication of where you are within the overall structure of a computer, a computing system. Okay. So introduction to CPU, and it starts off at really basics, like here's the processor and here's the memory, and this is what's in the memory, and we need to read and write out of the processor. And then it goes into different memory registers, and it slowly fleshes it out. So, and we've got this register transfer language, so we want to transfer information around the registers in the CPU, and it shows you a nice little register transfer language in order to do that. And it does pick a particular architecture to use as an example. Now the example that it tends to use through the book is the 68K, so this is the Motorola 68K assembly language, but it does cover some other assembly language stuff as well. So there's a bit in ARM, a little bit of PowerPC and so on, but most of it's going to be 68,000. So there you go, it's 68,000 family. Now it also covers here types of machines, so a 2 address machine, a 1 address machine, a 0 address machine. This stuff here was really quite interesting. Overview of addressing modes as well, which is very important. So it just gives you a brief overview of addressing modes, and then it goes through the 68,000 addressing modes. Okay, and the nice thing as well is that you could download a 68,000 assembler language assembler, and for free. I think this Easy 68, there's one it mentions in this book, and you can build up the assembly language yourself, and you can simulate it on that. Okay, stuff on subroutines, and that's that section finished. Okay, so that's the basics of the instruction set architecture, and then it moves on to an excellent chapter here called assembly language programming. So this was another chapter I've covered probably the most extensively through this book. So it does give us the basic structure of an assembly language program, how it's built up, and what each of the elements of an assembly language program are, and it really goes into minute detail, and again it's very wordy and very descriptive, which is really excellent when you're starting out. And here you see it's actually Easy 68 they use here, and the simulator. Okay, so you can download that still today, and you could put the programs in and you can run them yourself. So again, the whole area here of the digital design and the computer architecture, it's very hands-on, and you can go online and download tools, freely available tools, and you can build the stuff for yourself. That's what makes the whole area so interesting. And it goes through the registers for the 68K. Now I'll quickly move on here because I don't want the video to go on forever and ever. So again, it goes through all the different types of instructions that you would tend to use. So shift operations, using shift and logical instructions. And here's an excellent thing here, like templates for control structures. So you could have a high level control structure. So for k equals I to j, and then it would be next. So like a for next loop, and it shows you how you would build it up in a simple little bit of assembly language. Okay, and it's got all those different structures there for you, which is really quite handy. And again, there's a more detailed stuff here on addressing modes. So there's a lot on addressing modes in here. Okay, I won't go through and talk through all of it, but there's a lot. And the nice thing about the addressing mode section is that it's described graphically. So there's nothing worse than trying to understand addressing modes when someone just speaks the words. It becomes meaningless. You need to have the images. You need to see exactly what they mean all of the time here. So, and also goes on to the stack. So a very important part. So, and how we use the stack, and how we use the stack along in order to jump into subroutines and return from subroutines. And also how we pass parameters in and out of the subroutine using the stack. And again, I learned a lot from this, and I was able to implement some of the stuff in this book in my own CPU. And there's more larger programs here that it builds in. And again, you can test these programs out yourself. And then the next section here is the structure of the CPU. Okay, so so it builds up a basic architecture of a CPU, and it extends on it and expands on it, and it continually expands, and it works through a basic structure. Okay, now it also covers the basic structure of that CPU, and it codes it in C. So it writes a C code, which in effect is like a simulator for that particular CPU design. So you can have it all written out in C here. Now, there is a disk that you get along with this book. I don't have the disk, but I would imagine if you went online it wouldn't be difficult to find it. And also another section, the control unit. So this is really key to understanding the CPU. And these micro-coded operations, I built up these myself, not these particular ones, but the ones for my own CPU. And I've also got a spreadsheet in Excel that covers the same sort of control actions that you see here. Okay, so I took away from this book how this would be put together, and I put together an Excel spreadsheet in order to generate the same sort of things for my own CPU. And it also shows you physically how we're going to go from the opcode to the actual operation. Okay, and it's built up the little circuits here. So this is all excellent stuff, and it's sometimes difficult to find it explained so well in microprogrammed control units. Okay, so different variations on that theme, and micro instruction sequences and micro-programmed processors. So that's all excellent stuff. There's another bit in here about accelerating performance. Now, in this chapter here, the only part I was really interested in was the first little part about the RISC and a bit about RISC and CISC. Now, the other part I was interested in was the pipelining. So it does go through a nice section here, section 8.3, on a pipelined architecture. Now, it doesn't really show any details of a pipelined architecture. I do have, though, in a different book, a nice set of pipelined architectures, so in a different book. But in this book here, it does give you an indication of how it works. Okay. Now, I didn't bother too much about the memory stuff and the cache and memory. You can always have a look at that. It tends to get out of date quite quickly. Okay, so we'll quickly flick through this here. Now, the next section here is another section on processor architectures. So it goes through different processor architectures. I think the one it covers here it covers an instruction set here. So this is M68HC12 instruction set. So it does go through actual instruction sets. Okay. So that's also an ARM RISC and processor instruction set here as well. So there's a lot of detail here about the ARM RISC processor. I haven't covered all of this here. I've just flicked through to have a look, But if you're interested in that particular structure, then you'll get a lot of detail in this book. Okay, so I'll flick through this. Now, the latter part of the book is the part that I was less interested in. There's bits on the buses, input-output mechanisms, so a lot of that really is, some of it gets dated, but some of it is just, it always remains pretty much the same. For example, I/O fundamentals, and it's programmed I/O, memory mapped I/O. Okay, and interrupt driven I/O. So there's some of the stuff there was quite interesting. So the interrupt stuff was good, and some of the basic circuits, parallel and serial circuits. Okay, so there was some of the stuff in that chapter there was of value, and the last sections here, computer peripherals. Well, it's a bit dated, some of it, and but it's interesting to have a little look just to see, but you know, some of it is kind of out of date. You know, stuff on, well, there's LED display, CRT screens and stuff. Okay, so computer memory as well. I never really covered the sections on computer memory, but you can have a little look. I'll flick through here. So it's very detailed, a lot of words, a lot of descriptions. If I decide to have a look through some stuff in computer memory, I would quickly go through into this book first of all, just to give you a good overview. A section on the operating system as well, which is good just for a read over. Okay, and the final sections here, computer communications, I've left that out, so you can always have a look anyway, but that's not the main thrust of the book, I don't think. And also at the very end here, it's got the actual full instruction set for the MC68000, which is really quite handy. So that's the full book. As I say, probably for me, I knew the stuff on the basics of combinational and sequential logic. What I was really interested in was the central part of the book, really from chapter 5 to chapter 9. Okay, so quite a big chunk of the book, probably about over half of it here. Actually, probably the bit in the bus as well. So yeah, certainly about half of the book was the stuff that was really interesting for me. But of course, if you're just starting out, then you know most of the book will be of use or value to you. So that's all I have to say about this book. If you're looking for something as to start off in the whole area of digital design and computer architecture, this is certainly a book I would think about purchasing.